Assalamu alaikum and welcome. In this video, I'm going to identify time series data. So this is the step of identification of time series data. So the question is, what do you mean by identification of time series data? Let me remind you that in this video, I'll discuss identification of time series, and then I'll estimate the model, and we will select the best of the models, and later on we will put it all together. We may be using either simulated data as well as the real world data. So regarding identification of time series, the first step is the visual inspection of the data. So first of all, we would like to make line graph of the data, and we may observe the data, and we can guess whether the time series is stationary or not. So that is the first step in identification of time series. Here we have 4 different types of variables, and here we have variable 1, and this is the graph of this variable. This is variable 2, and we have graph of the variable 2, and here this is variable 3, and this is variable 4. So let us consider first this variable, and looking at the graph of this series is AR1, that is, this is autoregression of order 1. And if you look at the line graph of this series, this is a station. This looks like stationary. Regarding variable 2, this is also stationary, but this is moving average, and this is MA1 process. So both variable 1 and variable 2 are stationary. Variable 1 is AR1, whereas variable 2 is MA1. Variable 3 has an upward trend. There is an increasing trend in this data, and the mean does not remain constant over time. For example, the mean of this series between 0 and 100 observation is almost 7, and the mean between 100 and 200 is somewhere between 11 and 12, and the one between 200 and 300, that may be 22. So the mean change is here. So this is also AR1 with trend. There is an increase in trend. So this is not stationary. Regarding the fourth variable, this is AR1 with structural break. If you look at this graph, we can subdivide it into 3 sections. In section 1, the mean is constant between 0 maybe up to 150, and then there is a sudden shift in the mean between 150 and 320 or so. So here the mean is much higher than the mean here, and again after that the mean is also constant, but it is also this kind of graph of the variable is known as a structural break. There is structural break. So this one is not stationary because the mean is not constant over time, and this one is not stationary. So this is how we can use a visual inspection to decide whether the series is stationary or non-stationary. Regarding the variable 3, which has an upward trend, it can be stationarized. We can make it stationary by taking the first difference, and delta yt or yt star is equal to yt minus 1. Say for example t is equal to 12, then t minus 1 is yt 12 minus y11, and similarly y7 minus y6. And then when we take the difference of this series and we graph it, then it becomes stationary. So differencing can be used to remove trend, and it may become stationary. Let us assume that the process is stationary. There are three different types of processes that we may be interested in. The first one is autoregressive, and autoregressive means the regression of yt series on its own legs up to pth order. So yt is equal to a plus b1 yt minus 1 plus b2 yt minus 2 up to bp yt minus p plus epsilon t, where epsilon t is the random disturbance term, a is the constant, and yt minus 1 is the leg 1, this is leg 2, and this is a pth leg. The second type of the process is a moving average, and here yt is regressed on the disturbance term in time t, the disturbance term in time t minus 1, the disturbance term in time t minus 2, up to disturbance term in time t minus q. And here also there is a constant. And if we combine AR and MA, then we get autoregressive moving average. And here we use AR plus MA process. So yt is equal to A plus B1 yt minus 1 plus B2 yt minus 2 up to B subscript P yt minus P plus ut plus phi ut minus 1 plus phi 2 ut minus 2 up to phi q ut minus q. So this is a arma pq. So where p refers to the legs of own variable, and q refers to the legs of the disturbance term. Here are some notation that we may be using from time to time: ARP, MAQ, ARMA PQ, where PQ refer to the order of the process, that is the maximum leg of the process. In these models, epsilon t is a white noise disturbance. And what does it mean? What do we mean by white noise? An error term is a white noise if its expected value is equal to 0 and if its variance is equal to sigma square, which is constant. So both the mean and the variance of the disturbance term are constant, and the covariance between two observations, that is Et epsilon t and epsilon s, is equal to 0 if t is not equal to s. So it means that two observations t and s are independent of each other. When the mean of the disturbance term is equal to 0 and its variance is constant and its covariance is equal to 0, then it means that the epsilon t, which is a white noise, is independently and identically distributed. So it is a special case of normally distributed model. It is also known as ladies and gentlemen, I thank you very much for your attention. If you haven't yet subscribed to the channel, kindly subscribe the channel and click on bell icon so that you can get timely notification about my other videos that will be uploaded for you. Thanks for watching the channel and the video. I request you to share this channel and these videos with your colleagues, with your friends, with your students, so that maximum people can get benefit of these